Hello and welcome to this clip having a look at some selected challenging bond enthalpies questions. First of all, let's have a think about how we might want to deal with some of these. I'd always recommend using this equation, delta RH equals the total bond enthalpy of reactants, and take away from that the total bond enthalpy of products. So to be able to know what bond enthalpies we're dealing with and how many of each, it's always a good idea also to draw out the whole reaction using displayed formulae so you can visualize the bonds you're looking at. So as you count the bonds up, make sure you include every single one that you're given data for, and it's easy to miss one out and throw the maths way off if you're not careful. And finally, if you're working out an individual bond enthalpy, remember that bond enthalpies are endothermic, so you must put a plus sign next to your final value. Let's start with a multiple choice question. So this isn't working out a delta RH value, it's actually working out a missing bond enthalpy. So it's a bit like solving for X in maths. So you start by putting the equation on the right hand side like I've done. I've literally just cut and pasted it from up here down to here. And you put in the actual displayed formulae. So for example, 2 hydrogen molecules can be drawn like this. 1 oxygen molecule, O double bond O. And 2 water molecules have 4 OH bonds in them. And we need to find what the OH bond enthalpy is. So let's just separate our bond enthalpies into reactants that are given to us in the question and products that we're meant to work out. So I've color-coded the equation that I mentioned a couple of minutes ago. And I'm listing the bond enthalpies. And I'm going to make 4 times OH the subject. So to enable me to do that, I'm going to change my list of bond enthalpies in the reactants into actual numbers. And I can add them up to make 1370. So what I do is I swap the minus 4H6 with the 4 times OH and then divide it by 4. So that gives me plus 464, which is obviously answer C. And what's interesting is there are 4 OH bonds, but there's only 2 moles of water. Sometimes people miss that out. And if we have a look at the comments in the mark scheme from the examiners, you can see that they actually found that quite a lot in many of the candidates they were marking. And what's interesting is they say that this error could have been prevented by drawing out the bonds. So let's shift along to a structured short answer question. This one's 2 marks. It's doing the same thing as we've just done. So I'm going to suggest maybe that you pause the video and have a look at doing this yourself. So grab a piece of paper and a pencil. And don't forget to use these in your answer. Plus 436 for hydrogen, hydrogen, and plus 243 for chlorine, chlorine. Okay, welcome back. I'm assuming you've had a go at that. Maybe you've got a final value. Let's have a look. So again, writing out the equation and listing all the individual bonds, separating them in your mind into reactants that are given to you and product bonds that you have to work out. So doing the same thing as before, you list the bonds. You're aiming to make 2 times HCl the subject. You put the numbers in that you're given and you swap the 2 times HCl with the minus 184. Like so, and that gives you plus 431.5, and don't forget to put the positive sign in front of your final value. So what's interesting is they also mentioned that the most common mistake was to use the wrong sign when incorporating the enthalpy change into the calculation, or not to incorporate it at all. So let's finally move up to an unstructured leveled response. This will be one of the 6 markers. And they want you to find delta CH using bond enthalpies and also an unfamiliar enthalpy at A level that you won't have heard of before, delta vape H. So the first thing to do when you're presented with all of this text and data is to find what it is they want. So to locate the instructions is task number 1. And the next to do is to look at what parts of it are familiar. Well, you have an equation you can use, and you've also got some data that you can put into the same technique that we did before. So start by putting the equation at the top. Now, you might have spotted that the water is in gaseous form, but if you think about the definition for standard enthalpy of combustion, it requires the reactants and products to be in their standard states. Gas is obviously not the standard state for water, but this will be dealt with later. Now, why is it in gaseous form? That's because the bond enthalpies are all in terms of bonds that are found in the gaseous state, not in the liquid or the solid state. So let's leave it as a gas for the moment and come back and deal with that a little bit later. So once we've identified all the bonds, you can apply the equation that we've just been working on. You've got your reactants and your products, and you can list out the bonds, put in the numbers, and that gives you -2054 kilojoules per mole. So I'm going to put that working in logic into my answer that I'm going to present to the examiners. And now I'm going to come back and have a think about my enthalpy change of vaporization. Now that's connected to the water, isn't it? Because you can see it's H2O liquid going to H2O gas. Now we want it to be liquid, we don't want it to be gas at all. So we're going to have to go backwards rather than forwards in that reaction, or that change. So therefore, instead of plus 40.65, you're going to have minus 40.65. And you're going to multiply it by 4 because there are 4 moles of water that you're applying it to. So that gives us minus 2216.6 kilojoules per mole. Now, an important part of answering leveled response questions is to try to have some kind of logical flow to your answer so that they can see the sequence of thinking that you've done. So how do you apply that idea here? One way might be to put in a Hess cycle. Now, I mentioned earlier that we'd be looking at a bond enthalpy question that might need a Hess cycle. You can use a Hess cycle to justify the maths that you've got on the left-hand side. So you start with your basic equation, and you want it to be the equation that gives you 4 moles of water. In other words, the equation there is the enthalpy change, standard enthalpy change of combustion for propane. But what you worked out was the bond enthalpies, and the bond enthalpies required the water to be in gaseous form. So the minus 2054 that we worked out a bit earlier goes on the left-hand side, and your indirect route, which is the dotted line, takes you from the left-hand side to the right-hand side. Because when you combust propane, obviously it's an exothermic reaction, and the water is produced as a gas. So it's quite difficult to go from gaseous C3H8 and gaseous oxygen all the way to 3 CO2s and 4 liquid water moles. It's not going to do that in one step. So to take that second step into account, you've got to put your minus 40.65 times 4 on the right-hand side and add them all up, like I've got here, and that gives you minus 2216.6. So let's analyze the mark scheme for that question. Now, getting to 3 or 4 marks is fairly straightforward, because all you have to do is make sure that you've done the bond enthalpy calculation in the same way that we've been doing throughout this video. Now, in the mark scheme, they mentioned bonds broken. That's the same as the bonds in the reactants. And they mentioned bonds made, which is the same as the bonds in the products. Now, if you've attempted to link delta RH with delta VapH in some way and not got much further than this, you'd still make it to level 2. But that final bit is quite difficult, as we probably started to see. So let's have a look at what you have to do to get 5 or 6 marks. Well, obviously you'd have to do this first, and then you'd go and try and determine delta CH standard. Notice the standard sign here, this little one. Now, if you didn't reverse it and you got minus 1891.4, in other words, you just read it from the question and just plugged in plus 40.65 times 4, that might get you to 5 marks, but to get 6 marks, really, you have to have minus 2216.6. You have to recognize that final piece of deduction, which is that you're reversing the enthalpy of vaporization because you want liquid water. Now, where it says clear and logically structured, it's actually put in the mark scheme that it would include a correct energy cycle for delta CH. Using delta RH and 4 times delta vaph. That's actually quite tricky to realize that that could be useful. So the final bit of this question is actually quite challenging, although to get to level 2 is pretty straightforward by comparison. Okay, thanks for listening. Until next time, see you soon.